Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today, we're going to be doing Unit 10, Lesson number 8, combining rational expressions with addition and subtraction. In other words, we're going to add and subtract fractions. Now, in the last couple lessons, we've looked at how to simplify fractions and how to multiply and divide them. Today, we'll be doing addition and subtraction, and strangely enough, it will likely be the hardest day that we spend with rational expressions. Now, I wanted to kind of warn you about that up front, but just because it's hard doesn't mean it's not worthwhile. In fact, it probably means it's even more worthwhile because it's probably going to take almost all the skills you've developed so far with both polynomials and with rational expressions. So, make sure to stick with it. Don't get overly discouraged with how long the problems are, and you will get better at all sorts of different math throughout these. All right, let's jump right into it. Now, it is really critical before we start to add and subtract fractions that have x's in them that you understand some basic rules about how fractions add and subtract. All right, and the number one rule is that fractions have to have a common denominator. Now, you've been seeing this for years. You know this. I have young children myself, and already, as early as 4th grade, they're already adding fractions, and they know they have to have the same number on the bottom. So you can't take 1/2 and 1/3 and add the tops and add the bottoms. Ever. On the other hand, you can take 3/6 and add 2/6 and get 5/6. Now, I really do hope that you understand why you get 5/6. This is no different than saying I've got 3 oranges plus 2 oranges, and therefore I have 5 oranges. A sixth is a quantity. And saying I have 3/6 means I've got 3 of those things. And 2/6 mean I have 2 of those things. So if I've got 3/6 and 2/6, I've got 5/6. I don't have 5/12, right? I mean, I don't add those denominators. The second thing that you have to understand about adding and subtracting fractions is that denominators can only be changed by multiplying the overall fraction by 1, by multiplying by the number 1. So in other words, if I've got 1/2 plus 1/3 and they don't have a common denominator, then I got to change that into something that's equal to it. What do? Well, I take 1/2 and I multiply by 3 divided by 3, right? That's the number 1. Then I take 1/3 and I multiply it by 2 divided by 2, because that's also the number 1. And because I know how to multiply by fractions, I can then change that first fraction into 3/6, change the second fraction into 2/6, and now I can add them because they have a common denominator, right? Now, that procedure, I'm sure, is something that you're very aware of and that you've done many times. But now we're going to start to do it when there's variables involved. And once there's x's and y's and things like that, a lot of times for students, all the rules that they learned in terms of the way normal fractions work go out the window. But they don't. We're going to do exactly what just happened in number 2. We're going to do that time and time again, but with algebraic fractions instead. So let's jump into it. Let's do it. All right. Exercise 1 asks us to combine each of the following fractions by first finding a common denominator. Express your answers in simplest form. All right, I'm going to actually rewrite this problem down here so I have a little bit more room. Okay. Now, obviously, if they had a common denominator, I could just add the numerators, but they don't. This denominator is 4x. This denominator is 6x. I want to make a common denominator. The good thing is that they both have that x in them. All I need to do is worry about the 4 and the 6. Well, I can make them into lots of the same numbers, but I think I'm going to make them both into a 12. Now, to make that 4 into a 12, I've got to multiply it by 3. But I've also got to multiply the top by 3, right? I'm really effectively multiplying by 3 divided by 3. Likewise, to make this 6 into a 12, I have to multiply the denominator by 2, but that means I have to multiply the numerator by 2. Now, before I do any adding of fractions, first let me do the multiplying, and I have to remember to distribute. So here I'll have 6x minus 15, and in the denominator I'll have 12x. And here I'll have 8x plus 4, and in the denominator I'll have 12x. I've now got a common denominator. And as soon as I have a common denominator and I'm adding fractions, the first thing I do is I write that denominator down. I don't want to do anything silly like add them together and get 24x or multiply them and get 144x squared or anything like that. Now I've literally got 6x minus 15, we're going to speed this up a little bit in the next exercise, plus 8x plus 4. Now it's just an issue of combining like terms. I've got 6x plus 8x, which is 14x, negative 15 and positive 4, sorry about that, which is negative 11, all divided by 12x. I just added those fractions. There's only one final question I have to answer for myself. Is this fraction in simplest form? Right? Could I reduce that? Now here's where all of the math that you've been doing for the last few days has to come into play. In order to simplify something, you first have to factor it, and then you have to cancel common factors. So take a look at this fraction. Let me really just circle it in red. The only way we can simplify this is if we factor and then cancel. So let's look at that numerator, 14x minus 11. Let's spend some time on that. Think about whether or not you can factor 14x minus 11. And the answer is you can't. And since you can't factor, you can't cancel. So this is done. Now we won't always be done at this point. Sometimes we will have to simplify, but we're done. We're done at that point because we can't factor. We can't cancel if we can't factor. Okay, let's take a look at another one. All right, letter B. 4x minus 1 divided by 5x plus x plus 5 divided by 10. Again, the most important thing, these two have to be the same. Now, to turn that 5 into a 10, I'm going to have to multiply by 2. All right, but that's going to get me a 10. In fact, it's going to get me a 10x. So I have to have a 10x down here. Well, that's pretty easy. I'm going to multiply that by x, and I'll multiply that by x. So let's take a look at what we have at this point. Okay, that first fraction is going to be 8x minus 2 divided by 10x. And that second fraction, oh, be careful here, folks. That x distributes, and I get x squared plus 5x, all divided by 10x. All right, I've got a common denominator. As soon as I've got a common denominator, I write it down. Nothing funny here. Don't add those denominators. But now let's combine the numerators, and I'm going to skip this step where I kind of wrote it like this. Nothing will combine with the x squared. It is its own term. Then I've got 8x and 5x, and that's going to be 13x. And nothing's going to combine with that negative 2. So here I am at the stage down here. Again, question becomes, can we simplify that? Now, one thing that's wonderful is that the denominator is already factored, right? That's 10 times x. There's nothing I need to do to that. The only question is, can I factor that? Take a moment and think about it for a bit. All right, you can't factor that. And since you can't factor that, we're done. All right, this is my final answer. All right, why don't you pause the video and take a shot at letter C. It's a little bit weird, may even be easier than the other two, but take a shot at it. All right, let's go through it. Here's why I say it might be a little bit easier. First things first, let's look at the 4 and the 2. All right, eventually I'm going to have to make that 2 into a 4, but I'm not going to worry about it right now. I then have an x and an x squared. I got to make that x into an x squared. So to do that, I'm going to multiply the denominator by x, but that means I have to multiply the numerator by x. As soon as you multiply the denominator by one thing and you don't multiply the numerator by the same quantity, these problems are over. Okay, that is such a major conceptual error that really there's not much credit you can get. Now that's going to turn the denominator into a 4x squared. I need to make this one into a 4x squared, so I'm going to multiply that by 2 and that by 2, and that's going to get me a 4x squared down there as well. So let's take a look at what we have. That first fraction ends up being 3x divided by 4x squared, whereas the second fraction ends up being a 2 divided by a 4x squared. Notice I've got that common denominator, 4x squared, so I'm just writing it down. Now don't be fooled by the numerator. Here you've got 3x plus 2, and that's all you have, 3x plus 2. And just like before, the numerator cannot be factored, and therefore this is a done answer. Now I don't want you to get the wrong feeling, right? In each one of these problems, after I got a common denominator and I combined the numerators, there was no way to simplify the fraction. And that is very often the case. After you've added two fractions, you really can't simplify it. But we're going to see situations where you can simplify after you've added the fractions. So please don't get me wrong and think, oh, no, you know, he said put it in simplest form, but clearly we don't really have to do that because there's never any simplifying we have to do. It's rare, but it does happen on occasion. So pause the video now and write down anything you need to. Okay, let's get rid of the text and then let's move on to problems that are a bit more challenging, are a bit lengthier. Now, once we have more complicated fractions, as we do in exercise number 2, it is almost always best to factor basically everything that can be factored. And let me show you why. Let's take a look at letter A. Okay, now the numerator is just what it is, it's a 4. But the denominator I can write as 5 times y minus 3. Now the second fraction, the numerator is 5, not much there, and the denominator is y minus 3 times y plus 3. All right, remember, we've got to get the denominators the same, and we can only change them by multiplying. So the beautiful thing is, when we look at this denominator, 5 and y minus 3, and then look at this denominator, y minus 3, y plus 3, we already see a common factor, those y minus 3's. In fact, the only factor that this denominator is missing, the second one that is, that the first one has, is that 5. So I'm going to give it a 5, but I also have to give the numerator a 5. Now, they look pretty similar, but this one needs a y plus 3. So I'm going to multiply the denominator by y plus 3, and I'm going to multiply the numerator by y plus 3. Now, here's something that's going to seem really weird. Don't multiply out the denominators. Don't do it. I'm giving you permission. I'm telling you, I'm begging you not to multiply out the denominators, but you do want to multiply out the numerators. So in other words, in this first fraction, I have 4y plus 12 divided by 5 times y minus 3 times y plus 3. And in the second fraction, I've got 25, right? 5 times 5. 5, y minus 3, y plus 3. Remember, if I have any chance of simplifying this fraction, it's only going to occur if I can then factor and cancel. But the denominator is already factored, so what I don't want to do is sort of go backwards in order to go forwards. In fact, since we now have a common denominator, I'm just going to write that denominator down, and now I'm going to add the numerators. Nothing combines with the 4y, but I can add the 12 to the 25 and get a 37. So I now have 4y plus 37 divided by 5 times y minus 3 times y plus 3. Again, the question is, can we simplify it at all? Since we cannot factor 4y plus 37, this is what's known as prime. Since we can't factor it, we are done. That is as simplified as it's going to get. Done. That almost looks like the word done. All right. But factoring those denominators first was extremely important. Now normally after I do letter A, I have you work on letter B, but I think we should do letter B together. Okay, these are quite challenging problems, and it's really, really helpful to have somebody walking you along on them at first. You'll get lots of practice on the homework. So let's take a look. In letter B, that numerator I'm going to leave as x minus 3, but the denominator I'm going to factor into x minus 4 times x minus 5. All right, think about that for a minute. In the second fraction, I'm going to factor its denominator as x minus 2 times x minus 4. Now, I've done no adding yet. I've just rewritten the denominators in their factored forms. But right away, what you already see is that they contain a common factor of x minus 4. All right? And I have to make them look the same. Now, take a look at that second fraction. It's got a factor of x minus 2, and the first one doesn't. So it's going to have that x minus 2. But it also has to have that x minus 2 in the numerator. Okay, but now I can underline them in red, right? Now that's a common factor. But now the second fraction needs the x minus 5, so I'm going to put it there. At this point, we have a common denominator. What we haven't done is a lot of other algebra. So for instance, in this numerator, you've got to multiply this out. I'm going to do this fairly quickly. If I FOIL this out, it would be x squared minus 5x plus 6, all divided by x minus 4, x minus 5, x minus 2, plus 2x minus 10, that's easy enough right here, divided by x minus 4. I'm now going to write them in the same order. X minus 5, multiplication is commutative and associative. You can write it in any order you want. Okay, well now it's time almost for the grand finale. Now that they've got a common denominator, I'm going to write it as a single fraction, x minus 4, x minus 5, x minus 2. Nothing combines with this x squared, it just is x squared. Negative 5x, positive 2x is negative 3x. Positive 6 minus 10 is minus 4. Now we yet again ask the question, can I simplify? And here's the rub of it. This time we can. All right? And we can simplify because this can be factored. It would be factored as x plus 1 times x minus 4 divided by x minus 4, x minus 5, and x minus 2. Once we have it all like that, then we're really back to a couple lessons ago where we can cancel these two, and we're just about done. X plus 1 divided by x minus 5 times x minus 2. You could always multiply out the denominator at that point, but people rarely do. Wow, that problem was long enough that my hand literally hurts at this point. So let me rest it for a bit, you pause the video, and then we'll move on. Okay, clearing out the text. You see now why this combines so many of the skills that you've already seen, right? You have to be very good at factoring. You have to understand how to manipulate fractions and add them from, middle school. You also have to know what it means to simplify a fraction and whether or not we even have to do that. All right? So let's keep going. The next thing that we're going to do is subtraction. Now, subtraction works exactly like addition. You have to have a common denominator. You can only change the denominators by multiplying the overall fraction by 1, etc., etc. But there is one extremely tricky part. So let's take a look in letter A. All right? Now in letter A, you should notice right away that we already have a common denominator. So we don't have to do anything in terms of the denominators, which is really nice. On the other hand, the numerator is trickier because what we really have is 3x plus 7 minus x plus 3. And the key there is to distribute that subtraction, right? We're subtracting x and we're subtracting 3. Right? And when we do that, now it's easy. 3x minus x is 2x. 7 minus 3 is positive 4. And we get x squared minus 4. The only question at this point then is there any simplifying to do, simplest form? And the answer actually here is yes. That numerator can be factored as 2 times x plus 2. The denominator can be factored as x plus 2 times x minus 2. Cancel. And our final answer is 2 divided by x minus 2. There it is. Right? There's only one piece that is more difficult here, and that is the fact that when you subtract things, that subtraction has to distribute. We had to subtract both an x and a 3. Notice here it's x plus 3, but by the time we've done the subtraction, it's negative x minus 3, right? And that makes a big difference. Had we had negative x plus 3, we would have had a totally different answer. All right. Well, letter A was the first one where we kind of got off on the cheap, i.e. where we were able to just ignore the common denominator issue because they already had one. In letter B, immediately we're back to a place where that's not the case. And in fact, that means we should factor again. All right, so in that first new denominator, we've got the difference of perfect squares. All right. In the second denominator, which is considerably simpler, we just have a GCF. Once I've factored, I'm going to step back and I'm going to kind of look, and I'm going to feel good about stuff I don't need to worry about. In other words, the 2x plus 1 and the 2x plus 1, those are taken care of. But let's take a look at that second denominator. That second denominator has a 5 in it, and the first one doesn't. So I got to give it a 5. And I'll have to eventually multiply through by that 5. Now I look at the first denominator and the second one. They share both a 5 and a 2x plus 1, but we need a 2x minus 1, which I'm going to have to give to both of them. Now let's clean it up a little bit. That first fraction is 5x minus 15 divided by, remember, do not multiply these out. Silence. It's kind of like, talking right now. All that's doing is filling the quiet void. There it is. Again, here comes the tricky part. We've got everything. We've got the common denominators. We're ready to go. In fact, I'm going to write that denominator down. Whoops, or I'm going to apparently write it down incorrectly. I need a little more coffee. Right, there's that common denominator. Now watch what I'm going to do. I'm going to subtract, and I'm going to distribute this subtraction immediately. Now, when I distribute it to a positive 4x, it becomes negative. But when I distribute it to a negative 2, it becomes positive, right? A negative minus a negative becomes a positive. I can now simplify. 5x minus 4x is 1x, and negative 15 plus 2 is negative 13. Now, one thing that you're going to like in this particular problem is we can't simplify. And the reason we can't simplify is that the numerator is already factored, the denominator is already factored, and there are no common factors, right? The only thing that would cancel an x minus 13 is an x minus 13, and it's not down here. The only thing that would cancel a 5 is a 5. The only thing that would cancel a 2x plus 1 is a 2x plus 1, etc., etc. All right? So that one's done. Pause the video now before we go on and do a couple of them that will be even a little bit more complicated. Okay, I'm going to clear these out. Let's take a look at letter C. All right, letter C and letter D are as complicated as these problems are ever going to get. So remember, if you can make it through these, then you really, really are going to be comfortable with a lot of different skills. And even if you can't make it all the way to the end without making a mistake, stick with it. All right? All the other skills you're practicing, factoring, getting common denominators, combining expressions, They're all important in their own right. So even if you can't get through, don't get discouraged and give up and don't try, all right? You will get stronger at these. Let's do one more together, and then we'll have you do letter D on your own. All right, so I'm gonna put a big dividing line here because I'm gonna need a lot of room, and I'm gonna have to write small. So let's start. Step 1, let's factor. X minus 2, x plus 2, minus, over here, x, what would we have? Maybe plus 10, and x minus 2. Yep. Very often, once you've factored, you'll notice some common factors already, right? So I've got an x minus 2, I've got an x minus 2, okay? Almost always, I look at the second fraction and I say, well, what factors does it have that the first one doesn't? And what it has is an x plus 10. So I'm going to give this fraction an x plus 10 in both locations. That now means the x plus 10 is common. There it is. Then I look at the second fraction and I say, well, that thing doesn't have that x plus 2, so I'm going to give it that x plus 2. All right? At that point, what's beautiful is we've got a common denominator. Getting the common denominator is actually pretty easy in these things. Now, let's take it and let's multiply out the numerators. That first numerator is going to be x squared plus 10x. Here's the part that I actually dislike the most, is I've just got to keep writing out this very complicated denominator in its factored form, and that kind of makes my hand sore. Minus this one will be 6x plus 12, all divided by x minus 2, x plus 2, x minus 10. All right. Now, let's put that denominator down. X minus 2, x plus 2, x plus 10, and let's do some combining. Well, maybe not yet. Here we'll have x squared plus 10x. Here we're going to have minus 6x and minus 12. Remember, that subtraction needs to distribute over both of those. Let's clean it up. X squared plus 4x minus 12, all divided by x minus 2, x plus 2, x plus 10. Now the only question is there anything that could simplify? Let's factor that numerator. That's x plus 6 times x minus 2, all divided by x minus 2 times x plus 2. I'm going to have no room after these two problems are done for my head on this screen. It'll be teeny tiny. And look at those x minus 2's cancel. Whew. So my final answer is x plus 6 divided by x plus 2 times x plus 10. Yep, that's what I got on the sheet originally too. These problems are long enough where I could easily make a little mistake here or there, right? But I'm not going to let that get me down. I'm going to just keep kind of working on it, because the more I work on these, the stronger all of my skills get. All right. Well, pause the video now and take as much time as you need on letter D. Take up to like 10 minutes on it. You know, really kind of work on it carefully, systematically, and you'll either get it right or you'll get stronger at a lot of other algebra. Go ahead. All right, let's go through it step by step. Okay. First denominator. Factors as x plus 1 times x plus 4 minus. Second denominator. Factors as x plus 4 times x plus 8. All right, let's take a look. They already have a common x plus 4, so no worries. The second denominator has an x plus 8 that the first one doesn't. So I'm going to have to multiply numerator and denominator by x plus 8. Notice how I just immediately put that x minus 2 in parentheses, because I know I'm going to have to multiply two binomials. I'll have to use some kind of foiling process or however you multiply binomials out. This is Algebra 2, so you've been doing that for quite a few years now. Now that second fraction has an x plus 1 in it, or sorry, needs an x plus 1 that the first fraction has. Whew. But the beautiful thing is, we've got the common denominator. There it is, x plus 1 times x plus 4 times x plus 8. Wonderful. So now let's multiply out the numerators. Now that first numerator is a little bit more complicated to multiply out, but it's just foiling. It's x squared plus 6x minus 16, all divided by x plus 1, x plus 4, x plus 8, I'm going to be writing that down a lot, minus, that second one's pretty easy to multiply out, 8x plus 8, times x plus 4, times x plus 8, times x plus 1. I think I'm at a point where I think I want to combine these into only one fraction now. So that common denominator, x plus 1, x plus 4, x plus 8. Then this one is x squared plus 6x minus 16. And this one is negative 8x minus 8. Distribute that negative to both of them. All right, time to combine some like terms. Nothing combines with the x squared. 6x minus 8x is negative 2x. And negative 16 and negative 8 is negative 24. Whew. Divided by x plus 1 times x plus 4 times x plus 8. All right, at that point, the only question is simplifying. So let's factor that numerator if we can, and we can. That will factor as x minus 6 and x plus 4. Think about it a little bit. Yep. Divided by x plus 1 times x plus 4 times x plus 8. Look at that. X plus 4 cancels x plus 4. And we are done. X minus 6 in the numerator. X plus 1 times x plus 8 in the denominator. Ooh-wee. Wow. Yeah, that was great. That made me feel good. All right, there's a lot on this sheet. Pause the video now and take as much time as you need. Okay, I'm going to clear out the text. One last problem. Now, exercise 4 asks which of the following is equivalent to 1 divided by x minus 1 over x. Now, strangely enough, this is a relatively simple problem compared to the ones that we've already been doing. But simple is sometimes not good for students because they'll look at that and they'll go, oh yeah, no problem, I'll just, do a little bit of this, a little bit of that. And yet, we should still do exactly what we did before. So what I'd like you to do is pause the video now and think about how to do this problem. Okay, let's go through it. And I'd like to talk about a kind of a big mistake that students will make in this problem. Is they'll look at something like this and they'll go, oh yeah, no problem, I'll put a negative 1 here and negative 1 there. Can't do that. You can only change denominators by multiplying, not by subtracting. So that doesn't work. Now, again, it's tricky because these two denominators are very similar to each other, but they're not the same. And in fact, they're already factored. And if it helps, put parentheses around them, right? That means this first denominator needs an x. It's got to have an x. And the second denominator needs an x minus 1. But now they have common denominators, which is x times x minus 1. Look at how I'm trying to do this problem exactly like the last one, or the last set of problems, just a little bit easier. All right, now I'm going to distribute the subtraction, x minus x, but then it's plus 1, right? Because I subtract subtraction, and you get a positive 1. Now that looks like an equal sign. All right, let's finish. X cancels x, and we're left with 1 divided by x times x minus 1. I look at all my answers. I don't see it. Maybe I got to multiply out the denominator. and I have 1 divided by x squared minus x. And there it is. All right, pause the video now, and then we'll wrap up the lesson. Okay, let's do it. Well, here's the good news. This is probably the most challenging thing that we will do with rational algebra. Okay, adding and subtracting rational expressions. Now, that could be debatable. We've got some tough stuff to come. But adding and subtracting rational expressions is difficult. You've got to get common denominators. Once you have them, then you have to be able to combine the numerators successfully. To get common denominators, oftentimes you have to factor, and you have to factor quickly and effectively. There can't be any just sitting around going, yeah, I don't know, I'm not sure how that factors. You've got to really be willing to dig in. And even after factoring it, then you could run into the situation with subtraction, where you then have to make sure that you distribute that subtraction. But keep in mind again, especially when you take a look at the homework on this lesson, and especially when you get the solutions to the homework on this lesson, make sure you realize that just because your final answer might not be right, doesn't mean you should give up. There's great skills that you're acquiring, that you're practicing, and that you're reinforcing as you go through these types of problems. And that's more important than the actual problem itself. All right. Well, I want to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.